Your way to your seats. We're going to get started in a few seconds here. Good? Okay. Hello, everyone. My name is Jason Hill. I'm Associate Professor in the Department of Bioproducts and Biosystems Engineering. I'm also a Resident Fellow of the university's Institute on the Environment. I'm on the Healthy Food, Healthy Lives Advisory Board and am a member of the Planning Committee for this symposium. So in the first half of this morning, we learned about how what we eat affects our own health. And in the second half, we're going to learn about how what we eat affects the health of others. That's because producing food and delivering it to us, storing it, preparing it, all affects the environment. And those environmental effects affect ecosystems and circle back to affect us. Let me say this another way. What we eat affects the health of others. My dietary choices affect your health, and they affect the health of people around the world. I'll give you some examples of this. In the US, about 16,000 people a year die prematurely from fine particulate matter in the atmosphere, soot, small particles, as a result of agriculture. About 5,000 of those deaths are from corn production alone. Who here grew up being told that margarine was better for you than butter? A number of you? Okay, and then you guys switched and told us that butter was better than margarine, right? Get rid of trans fats in our diets. Well, in getting rid of trans fats, major formulations of food occurred. And what happened? Soy oil, partially hydrogenated soy oil, was pulled out and replaced with sugar and palm oil. Where did that palm oil come from? Indonesia and Malaysia. What happened there? Large amounts of rainforest were cleared to produce palm oil. Okay? So the recommendations of dietary recommendations affect the environment. Climate change then affects human health. So in the talks this morning, we're going to learn about some of those effects. Our first speaker is George Boody. He's currently the Science and Special Projects Lead, and until 2016 was the Executive Director of the Land Stewardship Project for 23 years. He co-directs interdisciplinary projects that measure and predict ecological and financial benefits from diversified farming systems and engage farmers. He received his master's degree in horticulture and human nutrition and a bachelor in science degree in biology from right here at the University of Minnesota. He'll be speaking on soil health, living covered and managed rotational grazing, implications for farmers, the earth and diets.
Thank you, Jason. I appreciate it. And I just want to say that Land Stewardship Project has 4,000 household members. I'll tell you a little bit about us. Our members include farm, rural, and urban members. And those, our farm members raise corn and soybeans for feed and biofuels, as they are. We also have mixed crop and livestock farmers, organic farmers, grass-based farmers, finishing cattle on grass, and vegetable and fruit farmers. So we have a range, but they're not the largest farmers in the countryside here in Minnesota, anyway. We also have a Bridge to Soil Health initiative and work in the Chippewa River in western Minnesota. We train beginning farmers, build community around food by connecting farmers and eaters, and advance public policy from our standpoint that puts people and land before corporate profits. And I'd like to talk a little bit today about the agroecological viewpoint of agriculture and some of the effects that it has, and the value of livestock on the land, particularly for our soil health. And that's especially the case with ruminants here in the prairie areas of the center of the country, in the Great Plains. They can digest cellulose. We can't do that. They can do something for us that we can't do through our other foods that we eat. And livestock manure helps enliven the microbial communities in the soil, and so they have that benefit too. So it starts with the soil. 95% of the food that humans eat is grown from soil at this point. Not everywhere. It depends on where you live, of course, but by and large, that's true. And the health of the soil underlies the health of the animal, plants, and the food that we as people eat. Again, depending on where we live. And what is soil? Well, it's clay, silt, and sand, but it's also organic matter. And organic matter is important because that drives a lot of the processes in the soil. There's air and water in the soil. They exist in the pore spaces. More organic matter, the more water that can be stored. So I'm going to depart a little bit from the dietary considerations because it's part of the whole system I think we need to look at. And importantly, soil organic matter is 58% carbon, and that can have a benefit to us in terms of climate change and in terms of pulling a portion of the carbon dioxide out of the atmosphere if we treat the soil right. It's important to know that the soil is living. It's full of living organisms. It's not an inert medium that we just put stuff on to grow food. And much of the soil function is mediated by a livestock in the soil, and especially soil microorganisms, bacteria and fungi. And they depend on plants for their food. So the more plants, the more cover, the better off those soil organisms are in large part. So we've got some challenges that we're facing, and that has to do with, in part, the way that the dominant models of agriculture are structured. They're highly productive, we know that, but there's many unintended side effects. And from an environmental standpoint, part of that results from confining livestock, removing them from the land in large volume. So then in that kind of consideration, manure, which is valuable for the soil, becomes a waste product that has to be disposed of, rather than a beneficial addition to the soil. We have hundreds of billions of dollars of a private investment in large multinational agriculture companies that sell technology for seeds, fertilizers, pesticides, and machinery to farmers and buy commodities from them. And farmers' margins are very, very tight. And sometimes the profit margins of the companies are fairly healthy at the same time. So that's a dilemma. And together these forces, they're powerful in driving policy, especially in the congressional side of that aisle. And together, those forces have been able to drive a lot of corn and soybeans onto the landscape, particularly soybeans. So that's a newer consideration. And that has an impact on the landscape here in the upper Midwest. And of course, there's further concentration of hogs. It started with poultry. Hogs and dairy are concentrated. So what I'm going to try to say to you is there's some benefits of shifting at least a portion of that back onto the land. And some farmers have opted out of the system, but most have followed the strong signals that have been provided to them by their bankers, by land-grant university research and extension, and by the products that are available to them to use and the structure of the markets that work very well. So that one of the implications on this is that there's not living cover on the landscape for most of the year, the way the system's currently structured. So really there's only living cover on the land in those yellow circles for about 120 days or so, depending on where in the country you are. And that has implications. The brown areas are areas of row cropping that have no living material on them during the winter. And the light green areas are perennials. Part of what we're seeing is declining soil health. So we're seeing significant erosion that can happen in the Midwest with the increasingly heavy rainstorms that we're experiencing with climate change in this part of the world. Here's a picture from the Chippewa River watershed in western Minnesota. Fairly flat land, tilled pretty extensively, not much residue on the soil throughout the year. And there's tile lines that run under those fields that drain water fairly quickly to the stream. That drains nutrients with it. We have a nitrogen issue running down into the rivers down to the Gulf of Mexico that can cause a hypoxic zone there that affects the ability to raise or catch fish at times. And we're seeing these kinds of ephemeral gullies that form more often, especially with heavy rainfalls when the land is uncovered and it's been highly tilled. This can be as much of a third of our soil loss from these ephemeral gullies, and 57% of the phosphorus loss, according to Rick Cruz. Oops, sorry about that. I'm going the wrong way here. There we go. Rick Cruz, a scientist at Iowa State University, says we're getting hammered by these kinds of storms, and then followed by sometimes periods of droughts after that. So what's the opportunity? The opportunity is to work with the living soil. And that means to minimize soil disturbance, for example, with reduced tillage. So some of you may have heard of no-till, for example. It's a way of planting in the previous residue or existing living crops that are there, and reducing chemical use, both fertilizer and pesticide use, potentially. We want to maximize diversity, keep the soil covered all year long, and also maximize living roots as much of the year as possible. Together with our colleagues here at the Greenland's Blue Waters, more green land, more blue water that we have. Here at the University of Minnesota and up and down the river basin, we call this continuous living cover. And I think in addition to what NRCS, the Natural Resources Conservation Service, talks about these principles of soil health, some there and we would advocate reintegrating livestock on the land when possible is another principle of soil health. And composting manure, for example. There's been some good research from the University of California that shows that composting manure can improve carbon sequestration on pastures as well. When we do this, soil health can turn soils into sponges, which is important for our water quality issues here that we're facing in the Midwest. Every 1% increase in organic matter means 25,000 gallons of available soil water that's stored. So it can be stored when rainfall is short, and it can be stored when rainfall is heavy. Gabe Brown, a farmer in North Dakota, started adding more species of cover crops, it's called, following his corn crop. And he's used 8 species up to 16 or more. He was able to increase his organic matter 2% to 5% in 10 years. So that's a pretty significant increase. Now what we've thought was true was that it takes a long time to build an inch of soil, many hundreds of years in fact. I think some of these farmers are showing we can do it actually more quickly than that, which will be beneficial to us. Here's a rainfall simulator. This is showing kind of the effects of rainfall. There's an arm that you can't see that swings water on here. And this is simulating about 1.5 inches in 10 minutes, which is pretty heavy rainfall. What you see here is that there are several systems being looked at. Poorly managed pasture, which is probably overgrazed, areas of brown, open spots in the soil, cover crop, well-managed pasture, and I'll talk a little bit about what I think that is, no-till, and you can see some residue on the top there, and then conventional tillage as you go to your right. It turns out that the conventional tillage didn't quite get the full amount of rainfall. Now, the jars in front are runoff, and the jars in the back are infiltration. So we want more infiltration than runoff. Also, I need to say that these soils were already saturated because there was 4 to 5 inches of rain prior to when this test was, or this demonstration was run. So looking at conventional tillage, there's pretty dark runoff there. There would be more if it got the full amount of the rain, and not too much infiltration in the back. Poorly managed pasture didn't fare very well either, so that's not a great benefit to us. A lot of runoff, it's pretty dirty. Well-managed pasture in the middle, very little runoff, almost none, and pretty clear infiltration. No-till, again, very little runoff, little darker infiltration, and then cover crops, somewhere in between. Well, some runoff, but it's pretty clear, and infiltration. So I want to show you that because we're talking about what will improve water quality here as one of the benefits. This is a visual example of that. Well, what's the why does continuous living cover, as we term it, and managed rotational grazing along with reduced tillage work? They enhance photosynthesis and soil biological processes. Plants take in sunlight, they take in carbon dioxide, they take in water and minerals from the soil. They release exudates along their roots. Dr. Christine Jones has called this liquid carbon. They actually attract bacteria and fungi to the roots. And when they do that, those soil organisms form glue and form aggregates along the roots. Inside that aggregate, carbon exists, and it can be stored there. It's resistant to further respiration by those organisms. And there's nitrogen inside those aggregates, too, that becomes available to the plant roots. A key is diversity of cover and depth and volume of roots. So here's a time sequence. We talked a little bit about Kernza last night, so maybe your question will come up later. But here's a time sequence with annual wheat and perennial wheatgrass, which is a precursor to a crop being developed here at Forever Green Initiative at the University of Minnesota and in conjunction with the Land Institute that's called Kernza. And I'm not sure we may be eating some Kernza at lunch. But in any case, what you see, this is winter wheat, is that the perennial has much larger volume of roots and deeper. And that's beneficial to soil health over time. Another aspect of this is here's plant roots trying to grab soil minerals by themselves. They can do it, but they're much more effective when they're linked with mycorrhizal fungi, which have these hyphae extending out from the roots into the soil. And these hyphae also connect plants if they're in proximity. So a grass plant like corn can be connected to a legume like soybeans or other kinds of legumes if they're in proximity, and they actually help feed each other through these hyphae. Hyphae extend the volume of the plant roots by 10 times and can draw in perhaps as much as 15% more carbon dioxide from the atmosphere. So they're critical to making this work. The hyphae are damaged by tillage, and they're not as prevalent when there's a single monocultural species. Well, what are some practical ways of making this happen on the landscape? Again, in conjunction with Greenland's Blue Waters. Perennial cover, one of the ways of doing that is managed grazing. Cover crops, planting crops following corn or soybeans. Longer crop rotations, extending the crop rotation by putting wheat as another year, for example, or oats, or alfalfa following that. That's a typical organic rotation, and also it can be done with using reduced fertilizer because there's legumes providing nitrogen to the following corn crop. There's new crops being developed as part of the Forever Green Initiative, pennycress and camelina, that can be used following soybeans as another crop that can have oils pressed from them, for example, we think. There can be agroforestry, so maybe we can get more nutrition from nuts. And certainly fruits, we know that. Some of those are tree fruits. And silvopasture, where cattle are commingled with pasture and trees, like a savanna prairie has been. Prairie itself can be harvested by animals for feed, especially late in the summer when the typical grasses around here go more dormant because it's dry, usually. and may be harvested for biomass down the road. So I think animals on the land, ruminants on the land, one way we do that is through managed rotational grazing. Some people call it adaptive multi-paddock grazing. The difference here is on your left, continuous grazing. Just the animals are out there. Kind of looks like a golf green with weeds coming out of it. On the right, this is Chad and Melissa Crowley. They manage their livestock this way. Rotational grazing, where there's electric fencing that's moved quickly, and the animals are grouped. It's a higher stocking density. They're moved sometimes hourly, sometimes daily, or sometimes longer. It all depends on where you are and what the rainfall is. Higher stocking density, shorter duration, more diverse plants in those pastures. The pastures now become productive instead of sort of the afterthought to the production system. And keep in mind that most cows, or most cattle, they're raised on grass in the first part of their life before they go into a backgrounding situation, and then most cattle go into a feedlot to be finished before they're taken to slaughter. Some cattle could be finished on grass, but it takes longer. There's almost no runoff from this, as we already saw. Teague from Texas has found about 3 times as much carbon can be sequestered in the rotational grazing, and perhaps better ratios of fatty acids, if that means anything to our diet. I'll leave it to our nutrition experts to tell us that. So what are some farmer stories? We work with farmers. That's part of what we try to do. And in our soil health initiative. So I want to tell you a couple stories. This is Rory Byer, who with Richard and Sharon raised milk cows, beef cattle, crops, hay, and pasture, and they transitioned their dairy to organic in 2009. They're focused on soil health, and they track organic matter and found an increase of 1.7% to 4.4% in 7 years. So for those of us that follow that, that's a pretty rapid increase. It's not a scientific study, it's an observation. So just to be clear about that. Tammy and Jess Berge raise lambs and cattle and have integrated cover crops into their cornfields. And this is cattle grazing on turnips. They actually eat turnips. And can graze on them in November, December, and January before the snow gets too heavy. And radishes and other covers are in here as well. Here's Jessica and Shane Blair. They bought 20 acres about a few miles from their home place. This field had been taken out of grass, put into corn and soybeans for 4 years. There was a major rainfall, and a foot of soil ran across that road onto the nearby U.S. Fish and Wildlife Service land. So some of the land really needs to be in grass, and cattle can be very beneficial in providing an income to farmers and food to us. Anyway, they have 60 species on that property now, and they've taken those lessons to their home property, have put 10 species of plants as covers between row crops, and they graze 40 cow-calf pairs and 300 ewes. And here's Sharon Wires, who's a soil scientist with the ARS Research Lab in Morris, and she's looking at a turnip there. You can see it in the corn crop and preparing to take soil tests. We use the Haney soil test, which is not popular here at the university. But nevertheless, we think it has some value because it allows farmers to track their soil health score. And that is beneficial. Organic matter is one feature of that, and a soil health score is another kind of feature. This is Grant, Dawn, and Carly Breikwitz. They bought some land. It was clay soil, had been abused over the years, too much tillage, only corn and soybeans. And they plant cover crops. They have a managed grazing operation, And they've grown their soil. There's about 2 feet of topsoil there. This is November day. The living roots are going down 30 inches from the cover crops. There's green material. There's earthworms that are active. And where that trowel is was a gravel road. So 8 years in, they built the soil 8 inches upward in 10 years using these kinds of systems. So it's powerful. These systems work on the land, particularly in the prairie areas of the Midwest where we are. Justin Morris, who is with the USDA's Natural Resources Conservation Service, he's a soil health specialist and visits lots of farms. He says livestock are the rock stars of building soil health. So livestock on the land can make a huge difference, and we can repair some of the damage that we have seen from an environmental perspective to the soils in these prairie areas, the way that they have been managed over the last few decades. Now, are people seeing improved carbon sequestration and soil organic matter in other parts of the United States? This is data assembled by Richard Teague from some other studies. He is believing that is possible. And typically, we thought that it's more like about 0.05 tons of carbon per hectare in terms of soil organic matter. So when we get 2 to 7 or 3, that's much higher than is typically thought is possible. One of the reasons he thinks that's the case is because, first of all, he's looking at systems that have already been shifted to that to some degree, so they're functioning well. It takes a while for the soil to restore itself, and also that they're looking deeper in the soil. So instead of looking 8 to 16 inches, looking as much as a meter down. I want to just play a short clip for you, if I can make this work. Let's see. See if it works. I don't think it's going to work, but what Tom Cotter said in this movie, I'll just play it to you. He has some of these same kind of systems. He has a canning crop. He says, you know, my reduced tillage is 1, my cover crops is 1, my grazing is 1. 1 plus 1 ought to equal 3, but actually it equals 5. So it's a principle of systems that the whole is greater than the sum of the parts. And that's what we're seeing with the potential of integrating livestock back on the land here in the Midwest. Well, from an environmental standpoint then, this is net emissions of a life cycle assessment study. Most of these probably assume, I would say, continuous grazing, which is not as productive. But this one from Michigan State University looked at what's called, we've talked about AMP or managed rotational grazing, and then their feedlot research facility. So the emissions are higher from cattle on grass because of the enteric fermentation. When they looked at the potential for carbon sequestration versus soil erosion, they got this green bar down here on the right as a net negative. In other words, they could sequester more carbon, at least for a while. For how long? I don't think we know. The assumption is maybe 20 to 30 years. But I don't think the soil only fills up. I think it can grow. To be determined. Here's another way of looking at that. This is Richard Teague, also Jerry Hatfield, who's the leader of the USDA's National Laboratory for Agriculture and Environment at Iowa State University, Ratan Lal, and others. And what they're looking at is what would it take to significantly shift greenhouse gas, reduce emissions from agriculture, and prompt more sequestration. So everything above the line is net emissions of greenhouse gases. Below the line is net storage or reduction. What they did is factor in soil erosion, which is not normally considered in these kinds of studies. And they found that soil erosion actually was a significant contributor of carbon dioxide. So you're exposing the soil to air and exposing it to more respiration. So emissions from agriculture may be higher than thought if you include that. They looked at reducing ruminants by 1/2, and their calculations were that that really didn't make that big a difference. It wasn't until we had more of a shift of 25% toward conservation cropping systems of the kind we've been talking about with cover crops and or longer rotations, and shifting some livestock out of confinement and into back on the land with well-managed grazing. The EPA figures that most of the emissions from agriculture are nitrogen oxides, mostly from soil management and manure, and methane from ruminant and digestion again, also manure management, and from rice. In terms of the percentage of U.S. greenhouse gas emissions in 2016 in total, that kind of center bar shift might reduce our overall emissions as much as 8% if we were able to accomplish it. Now, there need to be markets for this. A lot of things would have to change to make this feasible. It's not feasible overnight, but it's worth thinking about. Here's a study I just want to touch on by the Union of Concerned Scientists. It was just released, again, thinking about if much of the grass-finished livestock that we see is probably based on continuous grazing. Could we shift that to improve management? What about shifting grain-based feeds to more diverse growing situations and integrating animals on the land when possible? They too predicted reduced fuel use, reduced greenhouse gas emissions, reduced wastewater use, or reduced wastewater from the system. But what they're trying to look at here is reduced production amounts estimated based on both yields and feed efficiencies, but in units of reduced ounces of beef per week per person. So rather than saying we're going to have to take more land to produce the same amount of animals, what if we shift them onto grass, we can't produce as much, then do we reduce our usage of them? So what they estimated is that it would, at 2.6 million acres, an 18% shift of Minnesota corn and soybean acres would lead to about a 10% reduction of one standard serving per person. So that was the estimate from this study, just thinking about scaling up. And what they're looking at is a full pasture system, converting a third of corn soybeans to pasture, adding more oats and alfalfa into the rotation, and either harvesting them in scenario 2B and grazing them in scenario 2C, which has gotten gobbled up on this slide, so I'm sorry about that. Well, what about dietary implications? This is a study that took about 1,000 milk samples from farmers marketing through the Organic Valley brand, and this is looking at omega-6 to 3 ratios in these different systems. Fully grass-finished milk, which is grass milk it's called, or organic or conventional, and the ratios are the lowest of 6 to 3 in grass milk. Some people think we should be seeking lower ratios than we currently have in our diet. So I leave that up to you to decide if you think that's important. Also, more conjugated linoleic acid, which is another presumably beneficial fatty acid. Also, I think their point is that fish has more of the beneficial omega-3 fatty acids, but more people eat dairy than fish in the United States, so dairy might have more of an impact. And organic meats also have been found, at least by some studies, to have more omega-3s than conventional. So can this be done with other animals? Chickens and hogs might be able to be grown on the land, not to the extent that we do now. This is the Main Street project here in Minnesota exploring this. This is Eric and Lisa Klein growing chickens for this market here, and the Vanderpool's Pastures of Plenty pork, where their hogs are on pasture for a small portion of their lives. You can read more if you'd like to from our Pocket Guide to Soil Health, both about science and farmer stories. And just to point out, we're working on farm bill issues because that's an important driver of what's possible on the land. And crop insurance is one of the problematic areas right now. It mitigates against soil health, mitigates against more diversity on the land, and moving animals back on the land, at least a portion of them. So there's a number of things you might be able to do to the extent that you're researching continuous living cover system, or researching these issues. I urge you to consider the implications of what kind of products come from continuous living cover systems, and what kind of fatty acid ratios, for example, there might be in nutrition research. And also promotion. You can join groups like Land Stewardship Project if you want to help make some of this change possible. So I think there's some other reasons to grow food differently or to change our food system, but what I'll call attention to is that farmers have the highest occupational suicide rate in the United States. That's a problem, and that's related to the pressures that they're under with this technological treadmill that I mentioned. So we need to shift things. That's part of why we're part of the HEAL Food Alliance, Health, Environment, Agriculture, Labor, along with a number of other groups around the country. And I'll skip that one and just close here by saying I think we can grow red meat in ways that are maybe healthful for us. Certainly we can do that in ways that are healthful for the land, and that also applies to dairy. And what we need to do is learn how to mimic nature, because nature knows how to do this. We can learn from her. So thank you very much.
We're going to hold questions for after lunch for the both of these two speakers. Our second speaker is Mike Clark. Mark, I know Mike, he's in my research group. Mike is a PhD candidate in natural resource science and management at the University of Minnesota. His research revolves around how humanity's dietary choices affect human health and environmental sustainability. In his free time, he enjoys running, hiking, backpacking. I know he's a wonderful player of ultimate frisbee. Baking and cooking, and I can say from personal experience that his baking skills are fantastic. So Mike is going to talk a little bit today. Mike, let's get your presentation loaded up here while I finish this. Mike is going to talk today about some more global trends. You heard in the first talk about some of the local impacts of food production on the environment. Do you know where it is?
No, I emailed
No.
it to them.
Let's get out of here. Do we have? And Mike is going to describe some of his research, some of which is still unpublished, on the global implications of dietary change on the environment. So without further ado, take it away.
Excellent. So I will, can you hear me? Good. Yeah. So I'll be talking about how what we eat affects the environment, but before I start, I would like to take a quick poll of everybody here. Who here eats differently or has changed their dietary patterns for health reasons in the past? Okay, so most of us. Who has done it for ethical reasons? Most of us. Who has done it for environmental reasons? Also a lot of us. Perfect. That's not normal. It's generally people will switch diets for health reasons or ethical reasons, not so much for environmental reasons. But what often happens is that people overlook the impact that our diets and through our diets agriculture will have on the environment. So I'll start off just talking about where we are right now. And so right now agriculture is a major source of greenhouse gas emissions. It emits about 24% of greenhouse gases globally. This is approximately equivalent to the greenhouse gas emissions from electricity production. It's larger than all of industrial activities and is about 70% larger than the entire transportation sector. It also uses more than 70% of fresh water. Some estimates go upwards of about 90% of global fresh water. This results in stressed water basins, which also has other downstream effects such as biodiversity loss, reduced economic profits, reduced food security. Agriculture also occupies about 40% of Earth's land surface. If you take out Australia and Greenland, this goes up to about 50, slightly more than 50%. It can be found pretty much everywhere on Earth except for the polar regions, in the middle of deserts, and in the middle of tropical forests where there either aren't roads or they don't have access to markets to sell the food that they're producing there. We also use a lot of fertilizer to produce our food, which is not necessarily bad. The fertilizer applications that we do have increase crop yields, they help increase farmer economic profits, improve food security in under-yielding places. But the issue is when we apply excess fertilizer application, or in some cases manure application, is that results in nutrient runoff, which will result in biodiversity loss. It can harm human health through high nitrate and nitrite concentrations in water. What George also spoke about is that it can result in marine dead zones. And so this is a marine dead zone where fish cannot survive in the water because of excess nutrient pollution. And this one in the Gulf of Mexico was approximately the size of New Jersey last summer. So it's large. If you look globally, there are roughly 405 of them globally. So it's not an issue for just the US. It's also, agriculture is the single largest threat to biodiversity, partially because of climate change, because of water use, land use, and nutrient runoff. It currently threatens about 70% of mammals and over 80% of birds with extinction. So again, a relatively large impact. It's somewhat scary in terms of what agriculture is doing right now, but the good part is that we can actually do a decent amount about this as consumers. So the first part that we can do is, or the first part that I'll discuss about is the environmental impacts of different foods and how changing our dietary patterns might reduce these impacts. So this is a slide on the carbon intensity of food. It only contains, at this point, plant-based foods in green, then dairy and eggs in gray. What you can see here is that dairy and eggs have greenhouse gas emissions about 2 to 10 times larger than plant-based foods. Rice has higher greenhouse gas emissions than other cereals because of methane that is released when rice paddies are flooded. And fresh produce, in this case, has somewhat higher impacts than other plant-based foods because this is measured per calorie. Fresh produce, lettuce, tomatoes, apples don't really contain calories, so it's skewed because of that. So remember the size of these two gray bars compared to all the plant-based foods. This is now what animal products look like. So if you go from left to right, pork and poultry have impacts that are roughly twice those of dairy and eggs. The impacts of fish production systems, which are in blue, are highly variable and dependent on how they're produced. The T fishery is trawling fisheries, and the R aquaculture is recirculating aquaculture. So trawling fisheries are where nets are dragged across the seafloor. Recirculating aquaculture is where you consistently filter and circulate water between different pens or ponds or tanks. Those have higher impacts than other types of fishery and aquaculture systems because they require a lot more energy inputs. Then if you look at the far right, you have ruminant meat, which is beef, sheep, and goat. Those have high greenhouse gas emissions, which I'll talk about later. So this is putting plants back on the graph just to show the very large difference between plant-based foods and, at the other extreme, ruminant meat. So I'm going to plot this in a slightly different way to show that there's a consistent trend across different outcomes that we'll care about. And so same data, it's just horizontal with points for the mean average, or for the average impact in the bars to show the variation around the mean. This is now looking at land use and also nutrient runoff, two forms of nutrient runoff. There is, again, a very consistent trend where plant-based foods consistently have the lowest environmental impacts per unit of food that is produced. Dairy and eggs have impacts that are, depending on the impact that you're looking at, between 2 to 10 times higher. Pork and poultry are somewhat similar to dairy and eggs, sometimes higher. They're never lower. And then at the other extreme, ruminant meat consistently has much higher impacts than nearly every other type of food that we produce. The reason for this, specifically why animal-based foods have higher impacts, is because animals are somewhat inefficient at converting feed into food, into things that we can eat. So dairy cows are about 40% efficient in terms of converting the food that they eat into the milk that we can consume or the dairy products that we consume. So if you look at that in a slightly different way, that means that we have to feed a dairy cow about 2.5 units of feed for it to produce a single unit of milk for us to eat. At the other extreme, you have cows being raised for beef production, which are only 5% efficient. So again, looking at it a slightly different way, that means to produce a single unit of beef, you have to feed a cow 20 units of feed to produce something that is edible to us. So to make this somewhat apparent, compared to maize, so the food that we often feed cows in feedlots, cows generally emit about 100 times more greenhouse gas emissions per unit of food produced. They occupy about 120 times more land, and they result in approximately 50 times more nutrient runoff than does maize. So the second part of this is also, how is the food being produced? This is spoken about a lot in the media. Organic, conventional, is it grass-fed, grain-fed, is it produced locally, is it produced internationally, so on. And the first one I'll talk about is organic conventional systems, or organic and non-organic in this case. There is a huge amount of debate in this in the media, not so much about what we're eating, but more how that food is being produced. So what this figure shows is it shows the relative impacts of organic and conventional systems for different types of foods. The way to interpret this is that the dots on the graph are the average impact, the bars are the variation around that mean. Bars that are above the horizontal line at 1 mean that organic systems have higher impacts. Bars below the horizontal line at 1 mean organic systems have lower impacts. If the vertical bars overlap the horizontal bar, that means that organic conventional systems have pretty similar environmental impacts. So for greenhouse gas emissions, you can see that there really isn't that much of a difference when you look across all of the data. If you look at the total average, it's about 2% difference between organic and non-organic systems per unit of food being produced. So it's very small. If you also look at land use, nutrient runoff, and energy use, I'll start with land use. Organic systems often require more land to produce the same amount of food, and that is largely because of differences in nutrient management techniques. Organic systems don't always, but sometimes also result in more nutrient runoff per unit of food, again, because of differences in nutrient management techniques. In terms of energy, organic systems tend to have less energy requirements, largely because organic systems don't use inorganic fertilizer inputs. Producing inorganic fertilizer inputs requires a lot of energy to produce them. And so that's why you see that organic systems have lower energy requirements than non-organic systems. The one caveat to this is that this is a very narrow focus of the impacts of organic systems. You can also look at soil health, as George spoke about. You can look at biodiversity, carbon sequestration. There are some indications that organic systems are better for biodiversity, they're better for soil health, and they tend to sequester more carbon, at least in the short term, than non-organic systems. So there are differences. This is what I could measure. But there are other differences that people are concerned about. Another one that's often spoken about is grass-fed and grain-fed beef, which George spoke about a lot in depth, so I'm not going to spend as much time on this one. But this figure is laid out in the same way. Above the horizontal line at 1 means that grass-fed beef tends to have higher impacts per unit of food produced. Below the horizontal line means that grass-fed beef has lower impacts per unit of food produced. So for greenhouse gas emissions, so this does not account for soil sequestration. And so this is similar to what George showed for his greenhouse gas emissions per unit of food produced, that grass-fed beef often has higher greenhouse gas emissions because the cows live longer and they produce more methane during their lifespan. They also tend to require more land use, partially because pastures they're not necessarily as productive in terms of producing calories per unit of land. So you just need more land to produce the grass to feed the cows than if you're producing maize to grow the same cow. And then nutrient runoff is often because if the cattle manure is not collected, it will just run off into surrounding aquatic bodies of water, and that will have downstream effects such as either nutrient pollution or formation of new marine dead zones, as you have seen before. Again, this is a relatively narrow view of the potential impacts of grass-fed and grain-fed beef because this is what could be measured. The things that George discussed earlier in terms of carbon sequestration, potential soil health, biodiversity, are other different metrics where grass-fed beef may be better and probably is better than grain-fed beef. The last one that I'll talk about is the idea of sourcing your food from locally produced food systems. And so if you look at the US, some foods that you will consume here may travel 200 miles from the place where it's produced, such as pumpkins, to the time that you eat it, whereas at the other extreme with chicken, it will, on average, travel nearly 3,000 miles between the place it's produced and the time it gets to your table. And so if you look at the amount of emissions that transportation, or despite this distance that food can travel, its transportation emissions are a relatively small amount of the total emissions from producing that food. For dairy, chicken, red meat includes pork and ruminant meat in this case. And then cereals, that is generally 10% or less. For fresh produce, that goes up to 20% because of both refrigeration in big trucks, and also because fresh produce is sometimes air transported and made keep it as fresh as possible when you consume it. So a different way of looking at this is, say you have an ounce of cereal, say rice or wheat. If you stick that on a really big ocean liner, so one of the big freight container shipping containers, is that you can transport that ounce of wheat around the world 2.4 times before the emissions from transporting that wheat are equivalent to the emissions of producing it. If you do that for beef, you can transport around the world about 220 times. Sticking on a train is not quite as extreme, but in the case of beef, you can transport it around the world on a train about 22 times before the emissions from transportation are equivalent to the emissions of producing it. Again, there are probably other reasons why people are concerned about eating locally, such as local economics, you know where the food comes from. It may also be a cultural value. So this is only from an environmental perspective on greenhouse gas emissions. There are other things that you will care about and that people often do care about when consuming local foods or non-local foods. So if you take an entirely environmental perspective on this, it's the biggest thing that you can really do is transition your diet away from dairy, meat, and eggs and try to consume less of those foods and more plant-based foods. The difference in impacts of organic conventional systems or grass-fed and grain-fed beef or locally and non-local foods, those differences do matter, but compared to the difference that you might have between shifting your diet, is that those differences are very small. So we are unfortunately going in a direction that is not particularly happy, for lack of a better way of putting it. It's somewhat scary. So our population is projected to increase by about 30% by 2050. Much of this is in low-income and developing nations in sub-Saharan Africa, South America, Central America, and South and Southeast Asia. At the same time, so this is a video if it works. Sweet, cool. So this is a video showing how diets have shifted between 1961 to 2010, where, I'll play this again, where the size of the circle is how many calories each person brings into the household to feed them, and the different size of the segments is the proportion of that type of food that makes up the total caloric demand. And so the two things to look out for here are, in 1961, total or average global caloric demand was about 2,100 calories, 2,200 calories per person per day. In 2011, it was nearly 2,900 calories, just under 2,900 calories. The other thing to look out for is look how the proportion of calories from meat grows through time. So this change is not the same everywhere. In developing nations such as China, this change is occurring much more rapidly, both in terms of the number of calories that people are consuming and also how much meat they're consuming as a portion of their total caloric demands. So then if you look at places like the US, this is occurring much less rapidly. But unfortunately, even though in 1961 we already brought in about 2,900 calories per person into your household, we still increased our total caloric consumption by about 800 calories per day over the last 5 decades. So this transition is happening more or less globally, and you can see that here, where this shows how diets have shifted, where diets are measured on the y-axis is the total number of calories that people bring into their household to feed themselves. And the x-axis is how affluent the average person is. So what you can see is that as people become more affluent, they tend to consume more and in many cases a lot more food. But because, as I discussed earlier, some livestock, specifically beef production, is somewhat inefficient at converting feed into food that we eat, if you look at the total number of calories required to produce our diets, you get a similar trend but a very different story. And so this is what it looks like when you look at calories required to produce our diets. So it's, again, not where we're eating, but it also accounts for the calories in the feed that we feed to livestock. And so in the most affluent nations, we sometimes require about more than 8,000 calories per person per day just to feed what we are consuming, even though we might only be eating about 2,500 calories, maybe 2,000 calories. So that is, well, if you take this to 2050 and assume that those trends continue, that global greenhouse gas emissions from our dietary patterns are projected to increase by about 60%. Land use, or crop land use specifically, is about 30%, which is roughly 2/3 the size of the EU. Nitrogen runoff is projected to increase by about 40%, and phosphorus runoff by about 80%. So if we're already in a bad place right now, we're not going to be much better in the future. Again, fortunately, there are things that we can do about this. Mainly, it's eating less meat. It's not eating no meat, it's eating less meat when you can. The benefits of doing this are that if you eat a Mediterranean diet, which is generally classified as a diet that contains a lot of whole grains, a lot of legumes, fruits, vegetables, and some dairy and some meat, so both chicken, pork, and ruminant meat, is that eating a Mediterranean diet would reduce global greenhouse gas emissions by about, or global diet-related greenhouse gas emissions by about 15%. If you eat a pescatarian diet, so vegetarian with some fish, you would reduce average global greenhouse gas emissions from diets by about 40%. And as you eat vegetarian and vegan diets, you can get upwards of a 60% reduction in global greenhouse gas emissions. You'll also observe similar benefits in terms of land use, nutrient runoff. Pretty much any environmental indicator that you can look at, you'll see very similar benefits in terms of adopting a plant-based diet. The one other major aspect of what we can do to reduce our impact on the environment from our dietary habits is reducing food loss and waste. In the US, nearly 40%, a little bit over 40% of food that is produced is ultimately wasted. That means it's thrown away because it's either rotting in the refrigerator, it doesn't look good enough for a grocery store to sell to us for whatever reason. In most other regions, that varies between about 15 to 25%. And in the US, most of this is being wasted at our house because we either forget about it in the back of the fridge, we don't plan our meals, we decide to do something else. In less affluent nations, most of the food loss and waste is in contrast at the production stage or when you're trying to store the food. But the good news about this, in the US at least, is that because most of the food that we waste is in the household, if that you're a little bit more aware of the impact that food loss and waste might have, and the fact that we are wasting a lot of food here, is that if you make an effort to reduce that, you can also have an impact in terms of what your diet will do to the environment. One of my favorite examples of this is that a supermarket in France actually started trying to retail what they called ugly produce. And so they did this by putting it at the front of the grocery store and discounting it by about 25% relative to their other fresh foods. And so this was so successful that their direct competitors started adopting the same program. In other places, so this was in France, places in the US have started doing this. You've also seen, I don't know what to call them, but you've seen stores selling canned food that is past its best by date, which isn't technically expired. So there are other efforts outside the household that people are trying to make to reduce food loss and waste. Any questions?
As I mentioned, I do think we will hope, I'm sure there are a ton of questions on Mike's work. Jot them down because you'll have plenty of time after lunch to answer those. Do you want to say a few words on lunch?
So first of all, let's thank all of our morning speakers today. I think it was a great set of speakers. So now it's the favorite time of the symposium. It's lunchtime. So we will have lunch outside on the podium. If possible, we'd like to be back, say, about 1:10. We'll shave just a little bit off of lunch so we can try and stay a little bit on schedule. So 1:10 we'll be back here in the auditorium for the continuation. Thank you.